Looks good.
It's being synced, so
Yeah.
whenever you want, you can
Yeah.
go ahead.
All right, thanks. All right, it looks like we still got another 5 minutes before 5. But I wanted to just ask, how many of you have done distributed rendering before, where you're actually rendering on multiple processors at the same time? Yeah. Just curious which tools you were using. Anybody? Amazon, okay. Were you using any particular package or scripts, or just scripts that you developed yourself? Yeah. Okay. All right, interesting. Also curious, when we distribute rendering, we could distribute rendering by frames. So obviously, if you have an animation, you could use parallel processing to speed up an animation. How many of you guys are interested in the problem of subframe animation, where you actually have a still, let's say? Let's say you have a still that takes 30 hours to render, and you're interested in breaking that still up into pieces and distributing the rendering of that. Interesting. All right. That is something that Blender can actually do. I didn't realize this until recently, but Blender has the capability of breaking up a still and rendering the tiles, the rectangles of that still in parallel. So that's kind of an interesting development as well. And we'll look at some examples for that as well, how to distribute the rendering of a still. So I guess it's, we can start. It's about 5 o'clock. So I think a good way to start the discussion of cloud rendering is really, and there's basically one reason for doing cloud rendering. Well, there's actually 2 reasons. It comes down to cost, and it comes down to speed. And of course, cloud rendering always has to compete with the alternative, which is that you buy a rack of servers, and you own that rack. You can do whatever you want to with them. Physically building your own rendering farm using physical hardware is one option, and that's really been the traditional option. But the cloud offers a lot of the capability really of renting computers by the hour, rather than buying them outright. And there's some real economic advantages of that. For example, one can rent an 8-core VM on the low end for maybe 7 cents per hour. And that VM that you're renting might cost $1,000 if you were to actually buy physical hardware. So the question is, where exactly is that kind of dividing line where the cloud, rendering in the cloud becomes more advantageous economically than rendering on your own physical servers that you buy? And we're just doing a little bit of back of the envelope math here. Let's assume that the cost of buying the 8-core hardware is $1,000, and let's assume that the same hardware could be rented for 7 cents per hour, and we'll make some assumptions about the cost of electricity. What we end up with is kind of back of the envelope calculation, is that buying the hardware is about equivalent to renting the same hardware for 20,000 hours. It's a long time. 2.25 years of 24/7 usage. So the point here is that to really be able to compete with the cloud in terms of buying physical hardware, you'd have to really be using that physical hardware all the time, 24/7, to even get close to the economics of rendering in the cloud. There's another very important advantage of rendering in the cloud. And that is that if you look at the second paragraph, the cost of renting 1,000 hours of computer time in the cloud is the same whether we rent one instance for 1,000 hours or 1,000 instances for 1 hour. So in other words, we can really throw a huge amount of computing power at our renders, and at the end of the day, the price is essentially the same, because we're renting essentially computers by the hour. Now, when you have a major cloud provider like Amazon, you can actually go out there and say, I want to rent 1,000 computers for the next hour, and you can do that. And the price is essentially the same as if we had rented one computer over a very long period of time. So at the end of the day, you get your result a lot faster if you're using the cloud. And the cost advantage of using the cloud really is that there's no significant added increased cost to get your result faster. So let's talk about paralyzing rendering in Blender. It turns out that Blender, most people use the Blender UI, but Blender can be run by the command line, can be run from the command line, and it can be told to render a particular frame of a project. And this is very useful for this application because when you're rendering in the cloud, you're basically using a computer which has no screen or keyboard attached to it. It's just a computer in a data center somewhere. And so there's not going to be any UI. And so you want to have the capability of having Blender be able to run without a screen or keyboard attached. And Blender actually has that capability. You can start an instance on Amazon and you can run Blender and tell it to render a particular frame or a range of frames and to write the output of that frame, write the resulting PNG file to a directory. And that is kind of the fundamental building block that we're going to use to construct a Blender render farm. Now what I've done is, I'm giving this talk, but there's a side story to this talk, and that is that I've developed a series of scripts, and I've put them up on GitHub. This is essentially a command line package of Python scripts that really automates a lot of the process of rendering Blender animations on Amazon Web Services. So if you wanted to take a note of that URL, and there's a lot more content, there's a lot more information in the tutorial that's included in that package than what I can actually verbally discuss in this presentation. So that's really a good starting point. So let's talk a little bit about what Amazon has done and how that is interesting to those of us who want to render animations using the Amazon cloud. So one of the interesting things about Amazon is that Amazon not only has the ability to rent computers by the hour, but they've created a kind of a spot market that is akin to a commodity market, where there's basically a supply and demand for these computers in their data centers. Amazon has hundreds of thousands of computers in data centers all over the world. And one of the reasons why they rent out these computers is because the CEO of Amazon observed at one point that, obviously Amazon is an e-commerce site, and he observed that everybody was using their servers, everyone was buying stuff during certain peak holiday seasons like Christmas, after Thanksgiving, and they realized that they have all these servers that they're not using for most of the year. So they thought, well, hey, let's try to create a business model where we rent servers by the hour. Previously, nobody had really been doing that. And what this service has evolved into is really a kind of a spot market where I can go out and actually bid on a computer for an hour, and I can I can essentially rent a computer for a price which is determined dynamically by a market. And this is very good for distributed rendering, because distributed rendering is something that doesn't necessarily have to be done in real time. Right? You can start your render, and you might be more concerned with cost than about whether the render is executing at 3 in the morning. You might not really care whether it's executing at 3 in the morning. But the prices at that time might be much cheaper than at other times. And so one of the things that I've done with the software is I've really tried to optimize the extent to which the software can take advantage of the Amazon spot market, so that you can get the absolute lowest cost in your render. Now there's some implementation challenges for using the Amazon spot market, and one of those challenges is that, let's say that you have a render and you send it off to one of these Amazon virtual machines, and you say, I don't want to pay any more than 7 cents per hour for this virtual machine. Now, what may happen is that somebody else might come in and say, well, we're going to bid a little bit higher because we really need these virtual machines badly. And what the Amazon spot market will do is it will actually terminate your VM. Your VM will sort of just crash at that point. It will stop. And that's a challenge because if you're doing any kind of work, it's challenging when your computer could be essentially, the plug could be, the computer could be unplugged from the wall, so to speak, at any time. So how do you deal with that? And that's one of the things that I've done in the software is I've essentially created the software to be fault tolerant so that the software is able to deal with the fact that these instances can be killed at any time. And the reason why we go through all this trouble to deal with this unreliability is because we get the benefit of a much lower price. We can use these very low-cost spot instances. And that, of course, has a major impact on the actual final cost of rendering these animations. Because, again, a lot of this is about cost. Now, Amazon has a number of services, but there's one service in particular which is very useful to us. It's called SQS, Simple Queue Services. SQS is a queue, and we use it as a work queue. What that means is that we can divide our render into units of work. A unit of work could be a frame or it could be a subframe. And we essentially take these units of work and we pass them out to different computers that are running simultaneously. Those computers essentially execute the units of work. And the unit of work might just be, say, rendering frame 5 of your project or rendering frame 2000 of your project. And the product of that render will be a frame, a PNG file, which will then be stored somewhere for later access so that you can get that file and import it into your product and into your project and do the final sort of the video editing stage of your render project. But the Simple Queue service has a very interesting system built into it that you might call a system for acknowledging pending tasks. And the way you can think about this is let's say that I'm trying to render a simple job with 10 frames. So one of my computers in my render farm goes off and says, give me the first task in this project. So it gets frame 1. Starts working on frame 1. It finishes with frame 1. It pushes the PNG file to a file store. Asks for frame 2. But let's say while the render operation is in the middle of frame 2, let's say the spot market price of that particular virtual machine rises above our threshold. And now Amazon comes in and immediately kills that computer. So we rendered a part of a frame and then we were killed. Now, what's going to happen? Because we took frame 2 out of the queue, we were working on it, but we were killed before we could finish it. Now, what SQS allows is it allows us to sort of continue to acknowledge to Amazon that we're still working on frame 2. We're not finished with it yet. We're still working on it. We're still working on it. Now, if SQS doesn't hear from us for a certain period of time, it will say that virtual machine is gone. And whatever it was working on, let's put it back into the queue. So that frame that we were not quite finished with gets put back into the queue and something else can do it later on. So we don't have a hole. We don't want to have a hole in our render where there's missing frames because the computer that was working on those frames, got killed for some reason. And this is part of the whole model of being able to handle the unreliable nature of running jobs on these low-cost instances. So Simple Queue Service plays a very important role in simplifying sort of the management and infrastructure and staging of our job in such a way that we're able to reliably complete the job, even though the nodes that are actually working on the job are inherently unreliable. So what I've done is I've designed a tool. I'm calling it Brenda for Blender rendering on Amazon Web Services. And this tool is optimized to use the lower cost spot market on Amazon. And the goal of of Brenda is to be able to use these low-cost instances so that we can have a work queue, and the work queue, let's say, describes the frames in our project that we want to render. And what Brenda will do is it will handle the unreliability of having computer nodes be added and removed from the set of computer nodes working. Essentially, the computer nodes can be added and removed dynamically from the farm as time progresses. And the goal is to essentially stay in a consistent state. And most importantly, to render every frame, even if some frames are interrupted because the processors that are working on them are killed. Oops. So how does Brenda work? This is a very simple graphic of what Brenda is doing. Is we are starting out with a Blender project, a .blend file. We're including all of the support files for that Blender project. So bakes, any kind of information that would be needed to render a frame in that project. And we're packing it all together in a zip file or a tar file. And we're putting that in a file system that Amazon has that's called S3. It's a very basic file system, almost like a remote shared hard drive that you can push files to. So the way that Brenda works is that we start with our project. We put that project out there. The next thing that we do is we create a work queue. And that work queue is a small Blender script, maybe a one-line script that runs Blender and renders a particular frame. So if we have, let's say, 1,000 frames in our project, we'll have 1,000 different small scripts in that work queue. And the way that Brenda works is that it essentially takes work out of that work queue. It takes frames out of that work queue and passes them out to instances in the Amazon cloud. Those instances then go off and they render frames, and they put the finished product of those render frames into another S3 bucket. An S3 bucket, just think of it as a remote folder that's hosted on the Amazon S3 service. And so what Brenda actually does is fairly simple. And the code is fairly simple, maybe not simple, but it's straightforward. It's maybe 1,000 lines of Python code. It's not a hugely complicated project. And part of that is because it leverages on a lot of existing infrastructure that exists in Amazon. That normally, if we had to implement all of that infrastructure by ourselves, we would end up with a much more complicated problem. It would require a lot more code to implement. So what I'm going to do is I'm going to start actually using this. I'm going to start actually using the render farm to render a project. Now, one of the things you have to do to get started is you have to get an Amazon Web Services account, which is a fairly straightforward transaction. There's essentially no minimum monthly cost. So you're billed only for the services that you actually use. And I have a project that I've set up already. That's kind of big. Let's see if I can reduce the size a little bit. Okay, so Brenda accepts a very simple configuration file. On the top line, we're taking a Blender project that's called Marble Factory. And it's compressed. We're telling Brenda, we're giving it essentially a URL for the project. The project is in S3:// that URL in the top part of the screen. We're giving it a work queue. A work queue is, think of a work queue as just being a list of frames in the simplest case. So so the goal here is to create a number of different Amazon instances that will go off and process this work queue simultaneously, so that we'll get a faster result than we would if we were running this on one computer. So the first thing that I'm going to do is I'm going to list my project directory. So there's a number, this is basically a remote folder on Amazon that contains some files. And the file that we're interested in is this one over here, marblefactory.tar.xz. Now to use Brenda, we have to have something that's called a staging script. And let me highlight that here. This is a one-line script that will render a frame by executing Blender on the command line. It will render a frame in our project. And it's fairly straightforward. We're calling render in batch mode. We're telling it to render star.blend. Now there's only one Blender file there, so it's going to use whatever that one Blender file is. We don't actually have to name it. It's going to write the rendered frames to PNG format. And what we're going to do is we're going to make, let's say, 100 copies of this script for each frame, and we're going to push it into our work queue. And our work queue then will be the queue that we start our farm on to process. So let's go back to this file. So what we're going to do next is we're going to create a work queue. And what this command does is it's saying, take this script over here. This file source Brenda task scripts frame is essentially pointing to this file. And it's saying create 100 different versions of this script for frames 1 to 100 in my project and push it to the work queue. So let's try this and see if it works. There we go. So it's pushing now. It's going through each of these 100 frames, and it's actually pushing it to an Amazon SQS work queue. Now I can run Brenda work status, and I can see that I have 100 queued tasks. So each task is a frame, essentially. It's a task to render a frame. Now the next thing I'm going to do is I'm actually going to do something that is almost akin to looking at the stock market. Only in this case it's a commodity market. And it's a commodity market for computer instances by the hour. It's a very interesting marketplace that kind of, it's something new. We've never really, until a few years ago, we didn't really have this sense of having a commodity market for computer time. But computer time has been commoditized. Now I'm going to run this command, Brenda run price, and it's showing me, what this is actually doing is it's showing me the current market price for renting a virtual machine that's called an M1 medium, and it's showing me the price in multiple data centers. In this case, we're looking at the US East Coast. We're looking at 3 different data centers. Now, as you can see, there's one data center that the price is so unbelievably high that it's almost like it's $8 per hour. It's almost like Amazon is saying, we want to make sure that nobody actually renders, or nobody actually uses these instances because they're probably using them internally. So they've set the price really high. But this is a more typical cost that you would see for an instance on Amazon. It's 1.3 cents per hour. Now this particular instance, M1 medium, is a little bit low powered for what we're looking for. Probably the best price to performance in the Amazon cloud is an 8-core instance. That's going to give you relatively good performance, but the price is still reasonable. So what we're going to do is I'm going to go to my configuration file and save it. And what is going to happen now is when I run Brenda run price again, it's going to give me the spot market prices for a different instance that's a little bit more appropriate for rendering on Blender. So what we see here is there are some, in the US East 1C data center, we can rent this instance for basically 7.1 cents per hour. That's not very bad. What's that? What did I just change? What I did is I changed the instance type. These prices up here are for an instance that they call M1 medium. It's not very powerful. It maybe has only 2 cores. This is a higher end computer. It's called C1X large. That has 8 cores. So that's a good number of cores because Blender can take it. Blender is multi-threaded, and the render engine can take advantage of multiple cores. So we definitely want to, we want to throw as many cores as we can at this problem because it's going to optimize our final render time. So the next step is to actually put in a bid for these instances. It's almost like making a stock market trade, only the stakes are a lot lower. Yep. Yes, what I've done is in the package that I've released called Brenda on GitHub, I actually include an AMI. It's hard coded in the program, and that AMI points to a Blender to an Amazon image that has Blender and Brenda pre-installed on it. So it's very easy. You guys don't have to mess around with constructing the AMI because I've already done that. Yeah, question. I believe it's 269. It's whatever is available right now. Yeah. Yeah. Yes.
Question: is there any way or algorithm that could predict how much or what the best configuration or the best computer for you would be for your scene to render, the cheapest one?
Yeah, I don't have an algorithm like that in Brenda, but I don't think it would be very difficult to do that. What you could do is you could start up a number of different instances and measure the amount of time that it takes to render a frame in your project, and then you could multiply it by the cost and see sort of what the optimal instance is in terms of price to performance. And I kind of did that back of the envelope. I didn't do it rigorously. And it seemed like the C1 extra large was the right one. It sort of was right in between. It had relatively low price of 7 cents an hour, but it had 8 cores. That seemed like a pretty reasonable combination. Yeah.
Is there a way you can snapshot the VM if you know that you're going to get through? You can get in a large process rather than just letting it die. You snapshot it.
Yeah, that's a good question. You could snapshot it. You certainly could. What you could do is you could mount an external. I think it's called elastic block storage. You could mount a kind of file system that you could write your work to. The problem with that is that when you're writing data to a file system and you are killed, it's hard to make use of that data because you don't know what state it's going to be in. And I thought about this, and it seemed to me that probably the best way to handle this is to simply make your unit of work small. The smaller your unit of work, the less you lose if you get killed. And making the unit of work small is very important. If you're dealing with an animation where the render times are hours and hours per frame, you want to cut that down with subframe rendering so that your unit of work executes in a reasonable amount of time, because you don't want to lose too much. Now, one thing that Amazon does give you is they don't charge you for the hour that, essentially for the machine hour that you were most recently using when you do get killed. So what that means is that you're not necessarily going to lose money on this. You might actually end up with a cheaper render at the end of the day, because you're still obviously rendering frames and you're not paying for that time if they kill you before the hour is up. Question?
Yeah, with regards to the different versions, I know sometimes if there's a version change, there's going to be some compatibility issues with some of the other blend files that you've created in the previous version.
Right.
Are you planning to keep older versions of the AMI with a different version of Blender?
Yeah, I haven't done that. That would, obviously that would take some work. Now, one of the things that you can do is in the script over here, I can say AMI ID equals AMI dash whatever. I can configure my own AMI. You don't have to use the one that I set up. I set one up and I set it to the default because it seemed like it would save people a lot of time if there's something that's already made. Yeah.
How do you deal with data transfer if I have in my project like 1 gigabyte of extras and sending them to internet is slow? Is this an issue, or does it get loaded once to Amazon and then they do it?
It's loaded once. What you would do is you'd have a one-time upload of the data to Amazon. Now, you can compress that file as much as you want. So I don't know if you've ever if you use the best compression, for example XZ compression in tar, you can get quite a bit of a space reduction. Now, you only have to push that once to Amazon, and once that file is in Amazon, it moves very quickly between the nodes, and there's no cost for that data transfer within Amazon from the file system to the actual instances. Yeah.
I even thought that inbound traffic was free. No, it's not free. No, inbound.
No, it's not free. It's a slight. I believe it's slightly discounted, but it's not free. But the important thing is here, there's a lot of data moving back and forth, but it's all moving inside of Amazon's data centers, so they don't charge you for it. Now, if you have a project which is very large, if all of the support files for your project, if the project and the support files are, let's say, in the hundreds of gigabytes, then what's going to happen is it's going to take a long time when your instances start to actually download that data and start processing it. There's another alternative, though, and that's that you can create an Amazon machine image that already has all of your data pre-installed on it. And that is an option. So that when Amazon actually starts your instance, your entire project is already there in the file system. And I haven't actually done very much testing of that because I haven't worked with massive projects. But this would be an option if you're working with a project which is in the hundreds of gigabytes or terabytes. Yeah.
How much rendering is, the example you gave us with the render internal, is it?
Right. You can use whatever render engine you want as long as you can control that from the command line. So if you go to our task script, I'm not actually specifying the render engine here. I believe the way this would work is you would have the render engine specified in the .blend file, and then it would just use that engine. Yeah.
So in principle, can you composite have blend layers and cycles layers composite together for your output? The program will understand what that means.
Right. I mean, basically, what I'm doing is I'm trying not to understand too much about how Blender works internally. What I am doing is I'm creating a system where you can run Blender in a script, and whatever you can specify in the command line, and whatever you can specify in the project, Blender will handle that. But I don't try to get into the details of telling Blender things about your project which are really Blender specific. I'm trying to kind of step back from that and sort of just look at a Blender task as this opaque thing without trying to understand all the details of how it works. Yeah?
Do they have instances with graphics card?
They do, actually. They do have GPU instances, and that would be very interesting to analyze the cost-benefit of using a GPU. Now, if you use a GPU instance, you have to pay more money. So the question is, does it really end up saving you at the end of the day? Because if you want to accelerate your job, you can always just rent more instances. And yeah, I haven't actually done that analysis on whether the GPU would help, but those instances are available, and you can, in the Brenda script, you can specify what instances you want to instantiate if you want to try that. All right. Okay, so what we're doing now is we are looking at the current spot market price of the instance. We haven't started it yet. Prices are actually quite high, which doesn't surprise me because it's morning in the US right now.
Sorry about that.
Yeah, don't worry about it. Now, one of the things I can do is I don't necessarily have to start an 8-core instance. I could start a smaller one, and I could start it on demand, which means that it's guaranteed to start. There's no market, there's no bidding process involved, and I can do that in this case. So what I will do is I'll go back to my configuration file here, and I will uncomment instance type equals M1 medium. That's a lower cost instance.
By the way, inbound traffic is free. The XS3, that's why I have the price list.
Oh, really? Okay. That's
They
interesting.
probably figured out that whatever comes in will come out someday.
Right,
So
right.
they might as well charge the outbound traffic.
Yeah, that's interesting. So in this case, then, you would only be charged for retrieving your frames off of S3. All right, so what I'm going to do here is going to start a run. I think I might just use the on-demand market because I'm not sure that this is a good time to be using the spot market. Now, the thing with the spot market is it's very much dependent on supply and demand at a particular time of the day. One of the things that you can do is you can start a render and you can create what are called persistent instances. So you can say, I want my render to only run if the market price of these instances is 7 cents or less. Now, if the price goes up above 7 cents, your instances will be killed. But as soon as the price comes down to 7 cents, your instances will be restarted. So this is kind of one way that you could sort of take some of the hassle out of running instances in the spot market, where you're taking advantage of lower cost, with the lower cost associated with off-peak periods. Okay, so what I'm going to do now, this is a command. This is the command that would normally be used to start to request 4 instances on the spot market at 7 cents per instance. Now I'm adding the D flag, which says do everything but don't actually do it at the end of the day. And this is what the code would have done at this point. It would have created an AMI. It would have not created, but it would have requested that an AMI be instantiated, 4 AMIs actually, at 7 cents per hour. This is a one-time request. The alternative would be a persistent request, which means that whenever Amazon kills the instance, when the market price comes back down to 7 cents, it will automatically restart it. That could be a very useful feature when you want to minimize your costs and only render at off-peak times. And this is actually the way that Brenda works internally is it actually pushes a startup script to the nodes as they're starting up, and it executes Brenda on the actual remote instances. And those remote instances will take jobs out of the work queue, render them, and push them to a file store. So what I'm going to do is change this slightly. Instead of requesting a instance on the spot market, I'm going to request it on the on-demand market. So this is going to basically start 4 C1 X large instances on the on-demand market that will begin rendering my 100 frames that I staged in my work queue. So it did it. It gave me a reservation. That's what this number over here is. And I can look at what the current status is. So it has actually started the job. These are my 4 VMs. They've just been running for 23 seconds. So they're starting up. Some of this information down here is old information. This information is basically some old spot requests that I used earlier today when I was testing the software. And one of the things that I include in the Brenda software is when you're running 10 or 20 or 100 instances, you certainly don't want to have to SSH to each one manually to figure out, what's going on. You want the ability to parallelize the way that you interact with the cloud, so you can interact with it as a unit. What I've done is I've created a capability in my tool where I can run an SSH command on all of the instances at the same time and get the output from those instances at the same time. So I can say Brenda tool SSH uptime, and this will essentially go off to every render node, every instance, run the uptime command, and return the results to me. Yes, any arbitrary command can be run. Anything that you could do with SSH, you can do with this. So these are the 4 instances. Well, it's showing 3 so far. It's taking some time. Probably the instances have just booted up, so they're still a little bit slow because they're basically loading themselves still.
There are a few specialized render farm services at the website that offer this. Would you say that most often they would be more expensive than using this script on Amazon?
I think that this gets pretty close to optimal cost because of the fact that you're using a commodity cloud provider, and you're taking advantage of the lowest rates that this cloud provider offers during off-peak periods. 7 cents per hour is probably really not that much more than the electricity that it takes to power these computers. So it's, I haven't done a rigorous cost analysis, but I would think that this would be fairly competitive. Okay, so I can see by these numbers that everything is working. If you look at the column, if you look at the numbers on the left at 2.18, 2.05, those numbers would be really low if the computer wasn't doing anything. So the computer is very occupied right now. And we can actually run a command to really see what's happening. I can say Brenda tool SSH tail log, and I can look at the end of the log files on each of the render nodes. Now that was fast. So what you can see here is Blender is rendering. And each one of these represents the end of the log file on each of the render nodes. Now I can also look at the status of work. I can look at the size of my work queue to see how much work the render farm has done so far. Now, if you recall, when we started out, our work queue contained 100 units of work for 100 frames. I will run Brenda work status, and it's down to 92. So that number is going to continue to decrease as the render farm processes these frames. And when it gets down to 0, it doesn't actually mean that the render farm, it doesn't mean that the job is finished. It just means that the last job was given to a instance, and that instance may still be working on it. It's possible to configure the farm in different ways. To save on money, you can configure the instances to shut themselves down automatically when the queue drops down to 0. So that's a good way to make sure that they stop quickly and you don't get charged for any time that you don't actually need. I'm actually running this right now without that flag set because I want to make sure that if there is a problem that I can go back and look at the log files. I don't want the instance to just disappear and take the log files with it in case there's issues that come up with the software.
Sorry.
Yeah.
It may sound like a stupid question, but I mean, you have written this, this script that really makes things easier. Still, you are kind of an expert on that field. It's not that, I mean, if you're new to the whole thing, it's kind of a difficult task anyway. So, are you actually planning on maybe offering some service on doing things for other users? Actually, I mean, it would be great to have, just to pay you actually to send you a file and you do all this connection to the server and all the optimization you're actually have to know how
Yeah.
to run.
Yeah, I mean, that's a good point. I mean, if somebody could offer this as a service, I don't know if it can be me because I've already got my own business in a completely different field.
Okay.
And I'm just like, I've got so much work with OpenVPN. This is kind of something that I've been doing on the side. But anyone in the room is free, I've open sourced this. Anyone in the room is free to make a business out of this if they want.
Yeah, it would be great. I mean, I understand it. It looks quite simple, but still, obviously there can other problems occur, and you have to understand the whole thing. So, someone expert to do that would be really great to have. So, I mean, I can obviously do that, but
Yeah, there's a learning curve, but I think that anyone who can learn Blender, I think, can learn this.
okay.
I mean, I agree. This is a command line experience, but I think the command line really works here. I mean, this is an area where the command line is very strong. I think, having said that, certainly somebody could put a UI on top of this. It's probably not going to be me because I don't have a lot of time that I can work on this. But I've tried to do the best that I can and create something, that the Blender community can use that will simplify this.
Yeah, it's great what you have.
It's really fascinating.
Yeah. All right. Any more questions?
The API, the Amazon API that you're calling, are they all Openstack compatible? Can you run this on any data center that would be offering OpenStack?
Yeah, that's a good question. I really didn't go out of my way to try to make this extremely portable. I think there's certainly that would make the software more complex. I guess the question, I'm not familiar enough with OpenStack, but the question is, does OpenStack have something similar to a fault-tolerant queue system? Because a lot of the power and functionality of Brenda rests upon this Amazon service that's called Simple Queue Service, which really allows us to make a Blender render farm reliable on instances that are inherently unreliable. So I guess my question would be, to what extent does OpenStack have queuing capabilities like that? It's something certainly we can look at. I'm not sure that I'm going to be the person that can do that, though. Yeah. Yeah, question.
At the beginning you said that it's possible to separate
That's right.
Because if you have a cycles render that takes 30 hours, then you don't want that meshing is
Yeah, exactly. Let me let me just bring up a quick example of how that's done. So we were talking about task scripts earlier on when I was staging the work queue for the render. This is a task script for a frame. So when this task script is used, the smallest unit of work is a frame. However, we have another kind of task script, which is called subframe. It's a little bit more complicated. Now, this is something actually about a month ago. I put a question on the Blender committers group, asking if this was possible, and somebody came back and said, "Yeah, you can do it like this." You don't really have to understand what's going on here, but what's really happening is we are executing Blender, but we're injecting some Python code into Blender when we run it. And this Python code sets some parameters: border min x, max min y, max y. And what this is doing is it's taking our frame and it's splitting it up into rectangles, into tiles. And what we can do to take advantage of this using the Brenda tool, if I do Brenda work-h to get the help information. This doesn't format very well, does it? When you run the Brenda work command to stage your work queue, you can actually give it a subdivision x and subdivision y parameter. And what that does is it tells Brenda how many subdivisions to make on the x-axis and how many to make on the y-axis. So, for example, when we staged this initially, this was the command that we used to create the per frame staging. Now, what I could do is I'll start with that command, and instead of running the frame script, I'm going to run the subframe script. Now I'm going to put a D here so it actually doesn't, it tells us what we're going to do without actually doing it. I'm going to render 10 frames, but I'm going to give subdivision parameters for the x and y axis. So we're going to divide this into 4 by 4. So we're going to have 16 tiles. Thank you. And here, actually, this is a lot of output on the screen. What it's actually done is it's created a Blender command, including this little piece of Python scripting that will actually render a part of your frame as a PNG. Now, when you use this, you'll end up with each subframe actually being dimensioned to your full frame size, but only a rectangle on that particular subframe will be rendered, and the rest of it will essentially be black. And that means that you will need to recombine them as a final step in your process. Now, I don't have any post-rendering tools for doing that kind of recombination, but I don't think it's very difficult to take a bunch of PNG files that define different rectangles and just blend them together.
So actually, you utilize the border if you just cut out the border, you can Blender set a region that is rendered by ignoring the rest. This is what you are utilizing.
Right, right. Now, I did post a question. I tried to get back to the very knowledgeable person who explained how this could be done. I didn't really get a response, but one question that I had is when you are recombining these PNG files, how can you know which region of the frame is undefined and which region is defined so that you can blend it all together? Because the undefined regions are indistinguishable from black.
You can just add the 4 image. You add them, and the black is 0. So
Yeah, that's what I did. That's basically what I did. I have a small script. What I did is just as a proof of concept, I put together a small Python script to combine these. Now this kind of shows the way to do it in the sense of proof of concept, but this is way too slow for production use. Stitch.py, I'm just using the Python imaging library to basically load the image and go through pixel by pixel and basically take the pixel, if you have a number of black pixels and one of them is non-black, then use that one. And that's essentially what you're advising to do. So maybe that's the way to do it. But this would have to be, you know, written in C or C++ to have any reasonable speed.
Blender itself,
Yeah,
Blender itself in the
maybe it could. Yeah,
can do it fine.
yeah.
Alternatively, you've got a convention on your file names. You can just, if you have a convention on your file name, say which rectangle it is.
Yeah, I have that.
Just chop and do it.
Yeah, that's a possibility. Yeah, what I have just a simple file naming convention, which you can control with this line over here. This is basically what this is doing is it's taking the 4 parameters that represent that frame and making it part of the name. All right, any more questions? Yeah.
So I can write that this is not, your software is not really limited to Blender, right? You could use every software you want to use.
Yeah.
This command line.
Basically, yeah, there's just one. That's right. This could be a general purpose tool for many different kinds of distributed processing, not just Blender. The only thing that's really Blender specific, that's hard coded into the code, is that it knows about the Blender flags that are used to indicate start frame, end frame, and number of number of steps in the frame increment.
This is open source.
Yeah, it's open source, so that could certainly be changed. You know, one of the interesting things about this as well is I haven't even gotten close to testing the ultimate scalability of a solution like this. There's really no bottleneck in the software itself, because there's no aspect of this software which is really sort of experiencing the crunch of being a bottleneck in the system. This completely leverages on Amazon cloud tools to leverage. So to the extent that Amazon Web Services can scale, this should be able to scale as well. Yeah, question?
Yeah, to the topic bottleneck, if you use the Blender internal render and you use ray tracing, at the beginning you have some kind of acceleration structure. This is a process which is not multi-threadable. Are you familiar with this?
No, I'm not familiar with this. So you're saying that there might be applications that cannot be multi-threaded?
Yeah, I mean, Blender actually is multi-threading capable. So if you have 50 cores and it distributes the work on those 50 cores, but at the beginning, the very first, I don't know, 2 minutes, only one core computes the acceleration structure for the ray tracing stuff. So 49 cores are just idle.
Right. Well, one of the things that I've done is I know that there's a certain amount of startup inefficiency when Blender is first instantiated. And what I've done is I've provided the option where a unit of work can be multiple frames. So for example, if there's a lot of startup work that you have to do to render one frame, well, you could have a unit of work, let's say, be 8 frames, which means that every Blender instance is going to start up and it's going to render 8 frames before it exits. So you can amortize some of that startup cost over multiple frames. That's one approach you could take. Another approach would be, if you believe that having 8 cores is not helping your problem, well, just use a cheaper instance that only has 1 or 2 cores. And then you get more, you're going to have more VMs, but you're going to pay less for them, and you're not going to be losing out on having cores that you're not using. Yeah, question?
Not really a question, but I wanted to say a few things about the performance of the machines in the Amazon cloud, so people have involved. The 8 core you get on the Amazon cloud, it's not the same performance as the 8 core you get in your laptop. It's about half of that. Because it's, if you look at the specs, they say that it's equivalent of an A and B core like 10 years ago.
Yeah, I would think that it might be application specific. I mean, I know that in some of the work that we did, I found that the 8-core system was slightly faster than a 4-core iMac that's maybe a couple years old. So, yeah, maybe it's not as fast as an 8-core that you could buy today. That's true. But I think that, you know, at least for our problem, one of these 8-core VMs was rendering faster than a desktop machine that we had. Now, granted, it has twice as many cores, but the performance seemed quite reasonable for the cost. Yeah.
And another thing is about the availability of the machines. It can happen that the spot instances are not available,
Yeah.
or they're priced out of the question,
Right.
and then you get to get on-demand instances, and the on-demand instances are limited by Amazon per account.
Yeah, the on-demand instances are quite a bit more expensive, and they erase a lot of the cost advantage. That's why I've tried to design the software as much as possible to take advantage of spot instances. Now, the thing with spot instances that you have to understand is that they're really only at their most economical during off-peak periods.
And for some types of instances, for example, those with GPU, they are almost never available.
Right, right. Although I'm not really sure that GPU necessarily helps us here, right? Because if we want to make the problem run faster, we can always just, you know, we can buy more instances as opposed to paying a lot of money for an instance with a GPU. You know, it's something that probably deserves more analysis in terms of whether the GPU is really cost effective. Yeah.
Where did you specify the number of instances on the script?
That was done. Let me look at my history here. That was done right here. The dash N4 is the number of instances. Yeah.
I guess it's because my weird finance background, I'm curious about volatility. When you have price volatility for this, do you often have this that you have that you only need the volatility to spike, or rather you only need the price to spike over your threshold for 1 second and then you get killed?
Yeah.
Right? So it means that as long as you have a low volatility period, it's fine. You stay under. But have you experienced problems with this? Like it starts running, and then runs for 10 minutes, and you have a spike, and you get killed. And
Yeah, that happens all the time. But remember that if you run for 10 minutes and get killed, you're not charged for that. And you may have actually rendered some frames during that time. So all of that work is essentially free. So that's one of the advantages of the spot market is you don't have to pay for interrupted time, as long as your unit of work is less than 1 hour. Now, obviously, if you're rendering a big frame that takes 10 hours and you haven't subdivided it, then you are taking a financial risk because you could be rendering this frame for many hours and paying for those hours, and then you get killed, and well, you might get the last hour free, but you still wasted a lot of effort because you were killed before you could finish your work and you were billed for some of that work. So this is part of the rationale for using a very small unit of work and using the subframe capability of Blender as much as possible. But to get to your point, I've definitely seen the price spike sometimes, and I think that's just because Amazon takes advantage of the fact that it can, when it has a high priority job, it wipes out a lot of these spot instances and does its own stuff, and then it restarts them again. And the software tries to play well with that by being inherently redundant and fault tolerant and restartable. Any more questions? Yeah.
What happens when Blender crashes during rendering?
If Blender crashes during rendering, I've tried to set it up so that it will not stop the instance, so that the log file will still be there. You can go back to it and look at it. Everything that Blender writes to stidout or stidair is logged. So you should be able to, for example, we looked at the command that allows us to tail the log file. This will show us the end of the log file. So if if Blender produced any kind of error message before it crashed, that would be there. So you could see it and try to do something about it at that point. Yeah.
This is again more a question about Amazon than the render software. It seems to me that if I say start running when the spot price drops below 7 cents an hour,
Yeah.
then it's going to be fluctuating, everything fluctuates. So at some point it's going to be 7.1 cents an hour and my job's going to be killed. Is there any way to say start when it hits 7 cents, but I'm prepared to pay up to 10? Don't, any spike up to 9.
Yes. In fact, the way that you do that is very simple. You just say 10 cents is my maximum bid. It doesn't mean that you have to pay 10 cents. It just means that you will be charged up to 10 cents depending on what the market price is at that point. But Amazon will never charge you more than the market price.
Starts as the price drops to 10.
The
price is jogging around.
Yeah.
Briefly touching 10. Job starts.
Right.
That noise is enough to kill my job off again.
You could do that with scripting. I mean, the Amazon API allows you to query the current market price. So you could have a script that waits until that price gets to your threshold and then starts the job.
Say, pay up to 10.
Yeah, the way that you do that is you would start it when it comes down to 10, but you would give, when it comes down to 7, but you would give 10 as your maximum price.
Is that already included in your script, or is this something more that?
No, well, the ability to have a kind of a thermostat algorithm where you get triggered when the price reaches a certain low point, but then you have some wiggle room as it gets higher. That's not in my script, but that's not very hard to do with scripting because the Amazon API is very open and very well documented. What is in my script, well, it's not really in my script, it's just part of how Amazon works. It's a little bit different from how, let's say, the stock market works, is that, in the stock market, if you say, I want to buy something for this price, you're going to pay that much for it, even if you're overpaying, right? Whereas on the Amazon spot market, they're only going to charge you what they consider to be the current market price, even if you are willing to offer more at that point.
Would be a financial option. So I would say that if you manage to achieve this perfectly, you have a great career in hedge funds.
Well, it's interesting that you say that because I spent actually many years working in the financial industry before I started working with OpenVPN. Yes. Okay.
I was just curious if it's possible, like I've seen some other cloud services out there. Granted, perhaps Amazon has the best price advantage, but for something more stable, for example, if you want to get knocked off on the spot, are there any others you might recommend or might think you might want to consider?
I honestly, I'm not an expert on sort of cloud economics. I think that any time you want to have an on-demand instance, meaning that you want to have a service that is guaranteed to provide the resource, I think it's always going to be more expensive than if it's a spot market. And I think that the advantage here, the reason why the spot market is cheap is because a lot of applications can't use the spot market. If you're running a web server, you can't have that web server go down during peak periods. I think what's interesting about the problem of distributed rendering is I think that it's very well matched to the spot service because a render farm is essentially a non-real-time thing. You don't really care when it runs. You just care that it finishes consistently. Yeah?
Just out of curiosity, what's the largest job you used your own scripts on?
The largest job I used was actually a Blender project made by my son, who's sitting a couple rows in back of you. And it was the motivation for me getting interested in rendering with Blender. He made a fascinating animation after he had just been using Blender for a few months. And we started rendering it, and it was so slow. I mean, it would have taken weeks to render. And I thought, we should try to make this work a little bit better. His render, I would say it took about 250 computer hours. And I started it up on 24 Amazon instances, and it was done overnight. All right. So our hour is finished.
Just one last question. So
Yeah.
what then finally happens with PNGs?
Good question. They're here. Let's look at our status here. Brenda works status. We have 48 frames left. We can look at the PNGs. If you look at the configuration file that I'm using here, the PNGs are being written to this S3 folder. I can go into the shell and I can use a command called S3 command list, and I can list all of the files that are currently in that folder, and there you have them. These are the PNG files that have been rendered so far.
And there's this three command get or something.
Yeah, S3, exactly. S3 command get -r, it'll download them all. All right. Thank you.
It's kind of funny for me, I just left the finance industry. First real conference outside the finance industry. I mean, I feel like I didn't even leave. I was just thinking this in terms of options,
Right.
single share options and stuff. It was kind of funny.
Yeah, the spot market does have a lot in common with the finance. I worked in finance for years, so it's kind of fun to be experiencing it in such a different context. You know, you sort of.
It really is. The only thing